So now we learn how to add or subtract any two vectors. First, I'll give you the graphical method of adding or subtracting any two vectors. Then I'll tell you about the law of vector addition. So first, suppose we have two vectors. Say one is in this direction. Suppose this is your vector B, and another is in this direction, A. Then the addition of these two vectors, A plus B, if we add two vectors, then what you'll have to do is you'll have to join this. Suppose you have A vector here, is in this direction, B is in this direction, so we draw this B in this direction. So that will be your B vector. So what do you do here? What have we done here? We have joined this tail. This is known as the tail. Okay, in the graphical method, this is known as the tail, and this is known as the arrowhead. So we have the vector has got an arrowhead and a tail. Here also arrowhead and a tail. So what we do is we join this tail with the arrowhead of this A. So here we bring this B in this way. Okay, so here A plus B, then this line drawn here R vector, then this R vector is the summation of A plus B. So this is the graphical method. We have to join the tail with the head. Alright, so here what we have here is A. Suppose we displace the object from this position to this position, then again from this position to this position. So we have two displacements, one is A and one is B. So what is the final the position of the object here? So what is the final displacement? The resultant displacement, I mean. The resultant displacement will be this one. So here R, okay, can be called as the resultant vector. So this is the addition of two vectors. Now what about subtraction of two vectors? Suppose we have again two vectors A and B. If I want to subtract the two vectors, here vector A, vector B from vector A, then what will I do is I'll draw another vector which is opposite to that of B. So your vector B is in this direction, which is in this direction. What I'll do is I'll draw a vector which has the same magnitude as that of B, but it is opposite to B. These are known as opposite vectors. So here what I have drawn is an opposite vector. So here this will be minus B vector. And again we use the same rule. What we do is we join the initial position to the final position, and this will give you the resultant vector of the subtraction. So here this is your R. What you'll get is R vector. In this case we have A vector plus minus B vector. So here this plus can be removed. So here we have A minus B. So this is the subtraction of vector A from vector B from vector A. That is by drawing this opposite vector minus B vector. You'll get A minus B. So this R, I'll write R dash. Suppose R dash, because this is R here. So I'll write R dash. So R dash is equal to A minus B. So this is the subtraction, and this is the addition. So we have learned the graphical method of vector addition. Now we shall learn about the laws of vector addition. As I've told you, there are two laws of vector addition. One is triangle law of vector addition, and the other is parallelogram law of vector addition. So triangle law of vector addition. It states that if two vectors can be represented in magnitude and direction by the two sides of a triangle taken in the same order, then the resultant is represented completely both in magnitude and direction by the third side of the triangle taken in the opposite order. So if we have two vectors, say A and B, and these vectors can be represented by the triangle. So we have A vector and B vector. So we have two vectors, A vector and B vector. So these, say, are the sides of this triangle. Say PQRS, or just PQR. So these two vectors are represented as by the side of the two sides of the triangle PQR, which is PQ represents A vector, QR represents B vector. Then the resultant is represented by this third side, which is PR, of the triangle both in the magnitude and direction taken in the opposite order. Okay, so here this is the order in which we've taken from P to Q. Your vectors is from P to Q. A vector is in this direction, B vector is in this direction. If we take this vector, then it is in the same order. But if we take this vector in this direction, then it will be in the opposite order. So here your R vector, okay, I'll write here S, so that will not be confusing. So here your R vector is the resultant of the two vectors A and B. Okay, so here again I'll state, if two vectors can be represented in magnitude and direction by the two sides of the triangle taken in the same order, in this order, alright, you're going in this direction, so in this order, then the resultant is represented completely both in magnitude and direction by the third side of the triangle taken in the opposite order. So this is the order which we have taken. The opposite order will be in this direction. So this will be the direction of the resultant vector. So here your R vector is equal to A plus B vector. So you have R vector, this is A plus B vector. You can see this is similar to the graphical method. Then the next law, which is the parallelogram law of vector addition. Now this law states that if two vectors acting simultaneously at a point can be represented both in magnitude and direction by the two adjacent sides of a parallelogram, the resultant is represented completely both in magnitude and direction by the diagonal of the parallelogram passing through that point. So again here we have two vectors acting at a point. Let us say vector A and B. We have two vectors, A vector and say the B vector. So we have two vectors here, A and B vector, acting at this point, acting simultaneously at a point. And we can draw a parallelogram by using the two sides. So if these two vectors are represented as the adjacent sides of this parallelogram, P, Q, S, T. So if these two vectors A and B are represented as the side of the parallelogram PQST, then the resultant is represented by the diagonal of this parallelogram. So the resultant will be this, denoted by R vector. So here R vector will be equal to A plus B. R vector, sorry. is equal to A plus B vector. So this is the parallelogram law of vector addition, and this is actually equivalent to the triangle law of vector addition. So if you can see here, this B, here this side PT is parallel to the side SQ, and if we draw a vector B in this direction, if we draw a vector in this direction, then this vector is equal in magnitude and same as direction as this B vector. So this vector here is B vector, isn't it? So here again we have come to a triangle law of vector addition. So PQS, the triangle PQS. So we have two vectors again, A and B, and the resultant given by the third side of the triangle. So here this parallelogram law is equivalent to triangle law of vector addition. Now we know that vector has got a magnitude and direction. So now what is the magnitude of the vector R? What is this magnitude equal to? And what is the direction also? So now to find the magnitude of the resultant vector R, say we take this example of two vectors P and Q acting at the same point A. The resultant obviously is given by the diagonal AC. Now to find the magnitude of this resultant R, we consider this diagram. Here we have two vectors PQ, and the angle between these two vectors is theta, and this beta, okay, beta is the angle between the R vector and the P vector. So this will give us the direction. So beta will give us the direction of the resultant vector. So to find the magnitude, what we do is we extend this CE perpendicular to the vector P. Okay, so we extend CE and BE such that they are perpendicular to one another. So we have a triangle, a right angle triangle BEC. And again here, since the side AD and BC it's equal, they are equal and they are parallel, so we can draw another vector Q, okay, which is along the side BC. Now we'll find the magnitude first, then the direction. So to find the magnitude, let us consider this triangle AEC. So in the triangle AEC, what we have is AC square is equal to AE square plus CE square. So here in the triangle ACE, so in triangle ACE, what we have is AC square is equal to AE square plus CE square. Okay, so this is by using the Pythagoras theorem, isn't it? So we have the hypotenuse is equal, square of the hypotenuse is equal to the square of the base plus the square of the perpendicular. And from the diagram, what is AE? AE square is equal to, no, I mean AE is equal to AB plus BE. So here your AE, instead of this AE, I'll write AB plus BE square plus CE square. Then again, what you do is you expand this one. What you'll have is AB square plus BE square, then plus 2 into AB into BE, then plus CE square. Now we look at this triangle BEC. Now in triangle BEC, you can see clearly that BC square is equal to BE square plus EC square. So here your BE square plus this CE square, this will give you BC square. So here what we have is AB square plus this one and this will give you the hypotenuse, the square of the hypotenuse, BC, square of the triangle BCE. So then we have plus 2AB into BE. So that is your AC square. So here we have got the side which represents P and the side which represents Q, and here again we have AB, the side which represents the P vector. And now what about this BE? Here we'll have to write this in terms of the side which represents the vector Q. So again from the triangle the BEC, if we look at the triangle BEC, what is cos theta equal to? From the triangle BEC, your cos theta is equal to base, which is BE, by hypotenuse. So from triangle BCE, so here we have from triangle BCE, what we have is cos theta, this is equal to base by hypotenuse. Hence, by cross multiplication, we'll have BE to be equal to BC cos theta. So here instead of this BE, I can write BC cos theta. So into BC cos theta. Okay, so here AB represents what? The vector P, the magnitude of the vector P. BC represents the magnitude of the vector Q. AB represents the magnitude of the vector P. BC represents the magnitude of the vector Q. And AC is the diagonal. It represents the magnitude of the vector R. So I'll write all these in terms of their magnitudes. So what you have is R square is equal to P square plus Q square, then plus 2PQ cos theta. Theta is the angle between the two vectors. So here your R is equal to root over P square plus Q square plus 2PQ cos of theta. So this is the resultant of the magnitude of the resultant of two vectors P and Q. So this is same for triangle law also of vector addition. The magnitude is same. Since parallelogram law is equivalent to triangle law, so this is same. So in triangle law, what we do is we do not write this, we do not draw the parallelogram. We just draw the triangle ABC. Now come to the magnitude, the direction. How do you find the direction? The direction is given by this beta, angle beta, isn't it? So here you can see from the triangle ACE. Now from triangle ACE, what is tan beta equal to? Tan beta from triangle ACE. Tan beta is equal to perpendicular by base. So here from triangle to ACE, and this is to find the direction. So from triangle ACE, your tan of beta, this is equal to perpendicular CE divided by base AE. Now here CE, we'll have to write this in terms of the side BC, and the AE also will write it in terms of the side AB. So here what we have is this AE. This is from the diagram. You see AE is equal to AB plus BE. So this is from the diagram. Then again, what about CE? If you look at the diagram, triangle BCE, in triangle BCE, sine of theta. How much is sine of theta from triangle BEC? Sine of theta, this is equal to perpendicular by hypotenuse, which is BC. So again BC comes here. So here your CE is equal to BC sine theta. So here instead of the CE I'll write BC sine theta. Now BC is the magnitude of Q vector. So here we have BC sine theta. Now BE, I've told you earlier, BE is equal to BC cos theta. So here BE is equal to BC into cos theta. Now you put the magnitude BC as Q sine theta, AB as P, and BC again as Q cos theta. So that will be your tan beta. So hence the angle, this beta, will be given as tan inverse of this quantity. So that this beta will give us the direction of the resultant vector R. So there we have found out the magnitude of the resultant and the direction of the resultant. So the magnitude, remember, this is very important. The formula you'll be using in class 12 also. The magnitude is equal to, of two vectors P and Q, is equal to square root P square plus Q square plus 2PQ cos theta. And theta is the angle between the two vectors.